So hello again. So today what we'll be doing is an analysis of a composite structure, maybe some kind of a square or rectangular plate which is very minimal thickness, and we'll try to do some kind of analysis on a composite material, mix of materials if you will. So there are two ways that you can do this. So one is by using I think called the ACP, which is available here in the Ansys workbench. So you can use post and the pre. I'll show you how to do it. That is one method to do it. Another way you can do this analysis is the old version, like when this was not available. So this is a standalone application that's inbuilt now. So before, when this was not available, there is something called Ansys Mechanical APDL, where you can do the analysis as well. So in this video I will be doing the ACP version, pre and the post, and then in the next class we will take a look at how to do the same thing or a slightly different problem in the mechanical APDL. So to start with, I would need a few things. So let me first of all bring in ACP pre here. And I would, before I go into the engineering data, let's just draw some kind of a rectangular sheet. Okay, so we'll just go with kind of a sheet metal rectangle. Oops, I again started space claim, so let me just pause here and then open design modeler. Okay, so let me right click and then open design modeler. Wait for it to open. You can see the loading here in the bottom corner. So okay, so now we have our design modeler. It's just going to be a simple plate. Okay, so we'll just take the XY plane, we'll look at it, and dimensions. Okay, like we can just make some kind of rectangle. Okay, so we'll give the dimensions later on then. So this has to be okay. I forgot to change it to millimeter, and then we'll go to dimensions. Okay, since I first drew it in meter, then I changed to millimeter, we are getting this value. That's okay. Let's go for a 200 by 150. Okay, so let's go 200 by 150. I think that'll be fine. Or let's just 300 by 200. Fine. That seems okay. So 300, that means one side would be 150 mm. Okay, it's okay. It is coming like this because I unknowingly changed it later, right? So 150 and then another 150 here. And in this direction we need, okay, so that is 300, and in here we are going for 200, so it will be 100 here and then another 100 here. Yeah, okay, so this is the rectangular plate that we're going for. It's a 300 by 200 mm rectangular plate, and I think we're not going to create a solid here, we'll create a sheet. Okay, so go to concept, surface from sketches, and select our sketch number 1, hit apply and then hit generate. You'll get your sheet. Okay, so that's all. It's nothing fancy. We're just going to make use of this sheet as our base plane, and then we'll sort of go for a sandwich kind of composite maybe. Okay, as I do it you will be able to understand. So let's close design modeler for now. So we have created our geometry, everything is fine. Now next we need to load in some composite materials for us to work with. So let's go to engineering data. Okay, now here as usual we will see structural steel here. Let me just move this. Okay, Now we need some composite materials. Yes, you can click here, add your own materials, change the properties. You can do all that. If you're doing, trying out your own composite material, you can do that. But for the purposes of this tutorial, I'll just do it, much more easier with the data that is already available. So click here, this engineering data sources, and you can find a lot of materials already available inside Ansys. So what we need is the composite material. So just click on this. You can find several, different kinds of composite material components here. Epoxies, carbon fiber, e-glass, all those things are available here. You can make your own also. It's up to you. So let's say I want a honeycomb structure. Okay, so just hit plus. It will be added to the it will be added to the library. From the library, it will be added to the our workbench. Okay, it's the project workbench, so that we can access it. And let's go for I don't know, what should we go for. Okay, a pre-peg epoxy carbon. Okay, unidirectional. I think this seems fine. We'll add that as well. It has a 230 gigapascal. All these properties, you can just click on that and see the properties as well if you want. So these two I will add, and yeah, I think I'm happy with that. So we'll close that. That is also done. Now, yeah, we can go inside model now. So we'll wait for mechanical to open. Okay, just close all these unwanted things. Okay, so we have our rectangular sheet that is available here, and you can see all. Okay, unknowingly structural steel also came. It is not required for us, but that's okay. We'll just load over whatever is needed for us. Okay, so that is the honeycomb and the epoxy carbon. So that's okay, fine. So we have the geometry here, and I need to mesh it. So to mesh, I'm not going to go inside how I'm going to do, or all those things. So let me just see if I can make a good mesh here. Let's say an element size of I don't know, 10 mm seems fine. And let's just try to mesh it and then see. Generate mesh. Okay, it seems fine. It's alright, not bad. Maybe we can go for a little more finer mesh. Let's go with 5 mm element size and then update. Okay, I do not want. Okay, I need to generate mesh again. Okay, now this seems much more good. Again, you'll have to go inside the statistics of the mesh, take a look at the different, you can see the nodes and elements here. You'll have to take a look at the quality here, how good the mesh is, and only then you can advance further. But for the purpose of the tutorial, I think this is, pleasing to look at. We'll just assume it is good and then move on. Okay. So, okay, so the mesh is over here. We need to do the analysis now. So, we need to fix it somewhere and apply a force somewhere so that we can kind of study about the composite. So, as of now, we haven't given the material properties to the surface that we have here. So, let's do that after we give the forces. So, model is done. Okay, I'll just update the project. And what I'll do now is I'll go ahead, take my static structural. Okay, and then this I'll have to put it inside the model here. Okay, so basically the data from that will be passed on to here. Okay, and also one more thing that I'll need to do is okay, so I made a mistake there. Like I have to create this as a standalone system, and then I will have to drag the ACP. Okay, so this setup I'll have to drag to the model here. Okay, and this is just 2D sheet, right? So we'll just take the shell composite data. It's not a solid, so we'll just click on that and it will change into this kind of box now. Okay, with these options. So it will take the geometry and the engineering data and the mesh what we have done from the pre, and we'll be doing the small simple analysis here in the static structure. Okay, so before we go into that, let's go ahead, hit setup here. Did I not click it properly? Okay, I think it's taking some time. Let me just pause and see what's holding it up, and then I'll continue. Okay, so ACP is starting and it has open now. Okay, so last time when I clicked, it did not do anything because there was a small error that I had missed. So in the model, right, if you remember, the geometry data was not, let me go to model again and I'll show you. Just rewind the video and see, you will be able to see that. Okay, in the model, in the tree, right, that we have, let mechanical just open. Okay, I don't need any tips. Yeah, so if you remembered, like this was a question mark, like basically it had 0 mm thickness, so while going to composite it wouldn't understand what it had to do. Okay, so I just entered a arbitrary value 1 here, and then I was able to open up ACP now. Okay, so this is the ACP window that you get. You can assign all, you can basically create a virtual composite material here, if you will. Okay, not a material, like a model of the composite material. So what I will do here is I'll just set up a simple material here. So first of all, material data, you can see those two. We don't need structural steel anyway. So these two is what we require, that we have here, which is already loaded up. So what we'll need to do first is create a fabric. So right click here, create fabric. You can name it if you want. I'll just call it fabric. Okay, or let's give the name of the material itself, so I'll name this as carbon. Okay, and I'll select the material as epoxy carbon. Let's say it has a thickness of 0.25 mm. Okay, so I think yeah, that's it. So one is created. You can see all the background what is happening here in the bottom section as well. So one is carbon, and the next one that we have is the core of our material. Okay, which is going to be the honeycomb, and let's just say this has a thickness of 15 mm. Let's go with that. Okay, so we have our carbon and our core. Okay, now what we can do is we can go to stack ups, right click, create stack up, and you can give a name if you want, but I'll just go with stack up itself. So yeah, so here you can create how you want the models to be stacked up. Okay, so first of all I will go with carbon, and let's keep it at one at minus 45 and other at 45 degree angle. Okay, yeah, so we don't need to do any price for per area. Okay, here, so that's fine. So one stack up is done. Okay, and under that let's have another sublaminate. So I'll just call it sublaminate, and then here what I'll have is the first stack up. Okay, then I'll have one carbon, then I'll have another stack up as well, and let the carbon be 90 degrees. Okay, others the other two can be 0 itself, doesn't matter. Okay, it's again up to you how you want to create the composite. I'm just doing this particular I'm just following this particular mode, that's all, nothing else. Okay, now since stack up and the sublaminate is over, I can click on the rosettes, okay, and create rosette. So if you have studied composite materials and structures, you might know what is this, but for now we are not going to do any changes. We'll just leave it at rosette 1, or let's just leave it at rosette, okay, and then give OK. And then you'll have to create something called oriented selection set. Click on that, and here, okay, I'll give the name as set itself, you don't need it as 1. Now here there is an option for element sets, okay. So what you'll have to do here is click here and then click on the element sets, all elements, okay. So that will be brought down here, okay. And there is another option for okay, there was supposed to be something, point is here. We're not going to assign any rules here. So yeah, okay, the rosette is here. Okay, so rosettes, and then click on this rosette that we have, and yeah, I think that's it. Maybe orientation, this is mainly used for the result, so you can just give any you want, just click somewhere, that will be, that point will be brought here. So we'll give that OK. So we created an oriented selection. It's just for the results, okay, so it doesn't matter what you give. Next we'll go to modeling group. We'll create a modeling group. We'll call it we'll have a top, bottom and a core, okay. So I'll call it the composite bottom, okay, and then another one, composite underscore core, and one more, composite underscore top. Okay, so we have 3 of these created. Oops, okay, I just updated, no issues. Oh, I haven't saved the thing also. I hope it doesn't go away. Okay, so we created 3 of those. Now what we can do is, let's go to core first. Okay, right click. We'll have to create a ply. Okay, so create ply. Now oriented selection sets, we just created one, right? So click in between here and click on our set here, and what ply material you want. So this is our core, so we'll select our core, and angle we'll just leave it at 1. Let it have just 1 layer. You can increase the number of layers as you want, okay. So since this is the core material, we'll just go with 1. Hit apply. You can change the name if you want, it's up to you. Okay, so next let's do the bottom one. So create ply. Again, oriented sets, it's the same thing. We can just select from here, and ply material will go for the carbon. Let's leave it at 0 angle, so we're not going to change anything. Let's create 4 layers of it. Okay, hit OK. And finally top also we will have the same ply of carbon, and let's keep this angle as this has to be the opposite of whatever is going to be on the bottom. Okay, so we'll keep it at 90, and let this also have 4 layers. Okay, we are going to create a 4 layer with 1 core composite material where it's oriented 90 degree. The top one is oriented 90 degree opposite to the bottom one. Okay, so that's what we're going to do. Click OK. Okay, so now we have created kind of like a composite group here. So we'll just click on update here, and you can see this changes color, and let's see if I can rotate this. Yeah, you can see something has happened, right? So it has basically done all things that we have told it to. We have created a 4 4 8 plus 1 layer composite material here in the geometry that we have loaded. Okay, so yeah, that's it. We'll just hit on update. It is updated. Now we can close ACP pre. Okay, now what we have to do is we can update the project here as well, so that this data will be sent into our static structural now. As you can see, setup is ticked, and that data will be sent to the static structural now. Now we can do a simple point load or something. Okay, it's up to us what we can do. Now before I move any further, let me just save this project so that I don't lose anywhere. Let's see, Ansys. Okay, I'll create a folder. I'll Composite, and then I'll say ACP method. Okay, and then hit save. Okay, so it's necessary that you save because we don't want to lose any of our information that we have done, lose any data. Fine. So next we'll go into the setup of our static structural now. And this is the usual. Okay, we're just going to give force on some edge and then fix the other edge and see what are the deformations that happens along the composites. Okay, so yeah, we have our model here. Let's see. Okay, so mesh, see, and now we can see that all the plies that we have created, right, all those have come into picture here. Okay, whatever we have created, all those have come inside here. Now as usual, we can go to static structural, insert, let's say insert a force along this top edge maybe. So let me give the edge selection, let this be top for us. Let's say it's I don't know, some value, maybe 15 newtons maybe. Okay, so 15 newtons. Yeah, I want the direction to be along this inverted. Okay, yeah, so let's go for a force in this direction, and then let's fix it also. So a fixed support, let's see, where is it? Yeah, fixed support, and I'll fix this bottom edge. Okay, so that's quite simple. So you don't have to give any solution. You can do that if you want, but we can see the post results in ACP post. So we'll just hit solve then. Okay, so it will go through the solver, do all the mathematical modeling, and yes, the solution is over. So okay, just giving us some data here. This is not required for us. We'll just close this. Okay, now everything is ticked, right? So it's working, everything is good now. So to view the result, what we'll have to do is we need ACP post. Okay, so you take ACP post, okay, and you put it inside the model of ACP pre, and you'll get something like this. Maybe let me see if I can. Okay, he's not allowing me to move. Okay, that's okay. Let it be like this itself. And then what we'll have to do is we'll have to drag the solution from static structural and then push it to here, ACP results. Okay, post results. So now this is the schematic that we'll get, and we'll update the project. Okay, please wait. Okay, now we can see everything is green tick now. Now we can go into results, which will open ACP again, the same page, but it will be the post. And here, it's the same thing again, but we will get to see all the results now. Okay, so here you can see solution. We have solution 1. So let's go to There are numerous ways you can use this, but let's just maybe see the deformation maybe. Okay, so create deformation for all elements. Okay, and then hit OK, and then hit update here. Yeah, and you can see the deformation, how the composite has deformed here. Okay, now this is only showing as a 2D structure because that is how we have done, or that is how it is visible here. So there are ways by you can just click on solution here and create all these other things, and there are ways where you can study the individual property changes for the different layers also. Okay, so I'm not going to go over that now. You can just type in some YouTube videos to check that out if you're interested in that. Okay, so you'll be able to see the individual deformation that takes place along all the different layers as well. Not only the deformation, you can study about the failure as also stress and strains as well. Okay, so this is how you do a stress analysis on a composite material using ACP. And in the next video, I'll show you how we can do this kind of thing in mechanical APDL. It won't be as user friendly as this, but still that was one of the methods that was used in the olden days and still used by some people. So thank you, and I'll see you in the next class.